Hello, good evening everyone. I hope you've gone through yesterday's details or yesterday's lecture, what you've gone through. So, if you recollect, we have seen the basics of motion in a straight line, the concepts of initial velocity, final velocity, acceleration, distance or displacement. That is what we have seen. And further, if you drill down, we have seen the concept of we have started with distance slash displacement. Further, we have drilled down to the speed or velocity. Okay, speed or velocity. Then we have seen acceleration. Then obviously the time is anyways there. So overall, what we have said is out of these four parameters, these four parameters, any three will be given to you, and you are supposed to find the fourth parameter. Now, in this itself, I am not differentiating between V and U, that we will see the standard equations what are there, that we will see. Definitely in this lecture we will briefly touch upon this, but overall I am saying between u, v, a, s and t, these are the five parameters that will be given to you, and you play around all these parameters. Okay, now apart from this we have seen the concepts of average velocity. Apart from this we have seen the concepts of average velocity or speed, whatever, however you call it, average velocity or average speed, however you call it, that is what we have seen, average velocity and average speed. And then next important thing was instantaneous velocity, instantaneous velocity slash speed. Correct, instantaneous velocity slash speed, which we have told that instantaneous velocity or speed is nothing but the the velocity at that particular moment. Velocity at that particular moment is the instantaneous velocity. Now there are different cases, there are different scenarios which you are aware, couple of them we have discussed in terms of different concepts like train cases, speedboat cases, average velocities, etc. and all. So let's start off with couple of, we'll see few problems here, we'll see few problems like how we'll do, etc. and all. Then we will start off with the other concepts of where we have seen the graphs, the differential formulas, the integral formulas, etc. and all. Slightly we will go there. Okay, now so let's take down this question, okay, let's see couple of questions based on yesterday's concepts. Simple ones, very simple. All you have to do is understand the question well, and then you can do it. Okay, now the question is, a car travel, all these questions whatever we are going to discuss are previous year's papers in NEET or EAMCET, etc. All these questions are previous year's papers questions, and like I've told you, uh, units and dimensions, vectors, and motion in straight line or motion in one dimensional, all these topics are boundary balls. Okay, you definitely have to go through, and you definitely have to answer the question correctly. Okay, it's a simple topic, easy topics, nothing difficult questions or nothing this thing. So all you have to do is understand the concept, understand the question well, and if you put this scenario, half of your job is done. Okay, then all you are supposed to do is take care of your formulas correctly, application of those things, and then you are through. Clear? Now let us start off with few questions. We will see few questions today, and then we will move to the other concepts now. Okay, to start off with, a car travels first half distance between two places with a speed of 30 and remaining half with a speed of 50. The average speed of the car is. Simple question. Okay, simple question. A car travels, let's assume it is traveling from A to B. Okay, let's assume it is traveling from A to B. The first half that is till d by 2. Okay, because it is half, I have taken d by 2. It travels with a velocity of, or with a speed of 30 meters per second. The remaining half, the remaining d by 2, it travels with a speed of 50. Clear? Okay, now First half of the distance it travels with 30, the second half of it travels with 50. Now the given question is, what is the average speed of the car? What is the average speed of the car? Okay, very simple question. Average speed is nothing but average speed. Okay, let's take speed is nothing but total distance by total time, correct? Now if I am talking about total distance, it is nothing but d. From a to b, my distance traveled is d, correct? D, correct? Now what is my total time? Total time taken is nothing but, let's assume for a second this is, let's assume this is c. Time taken between a and c plus c and b, that is my total time. Now what is my time? You all know time is nothing but distance by velocity or speed. In this case, distance by velocity or speed, correct? What is the distance that we have assumed? It is d by 2. Okay, what is the velocity or speed that they have given? 30, plus the remaining half of it is what? D by 2 divided by 50, correct? That is the speed that they have given. Clear? Understood? Now from this, all you have to do is find the LCM. I can take d common and entire thing I can cancel it out. If you solve for this, you get 37.5 meters per second. Okay, if you solve for this, you get 37.5 meters per second. Okay, more than the solution, I am interested and I want you to give a thought on the concept that we have taken, where it says first half of the distance it travels with 30, the second half of it travels with 50. That is why they have asked you average velocity or average speed. Do not assume that 30 plus 50, that is 30 plus 50 divided by 2 is what I will do. No, don't do that. Okay, do not do that mistake. Clear? Understood? Got the question? Now similarly, an extension of this, let's say an extension of this in similar ways. Now yesterday also we have discussed, if you see, yesterday also if you have discussed, if you remember, yesterday also we have seen that the average speed, okay, the average speed or the distance, to start off with distance, we have told it is always greater than or equal to displacement. Why? Because displacement is your shortest distance. Displacement is your shortest distance between any given 2 points. Okay, while distance you can have hundreds of values, you can have hundreds of paths, but displacement is always, there is only one answer to that, because you are going to take the shortest distance. Now because we have said this, can I go ahead and derive a similar analogy between speed and velocity? Tell me, if the given question is, the numerical ratio of average velocity to average speed, the numerical ratio numerical ratio of average velocity to average speed is, think about the answer. Okay, think about the answer. No, I mean the options are similar: less than 1, equal to 1, less than or equal to 1, greater than 1. Okay, think about this. What can be the answer? Just take 2 minutes of your time. Simple question, you can get it easy. Similarly, like how we have seen the distance, it is it is nothing but the ratio between velocity and speed. Can I say the ratio between velocity and speed is nothing but my ratio between displacement and distance? Ratio between distance and speed, or my velocity and speed, is nothing but displacement between distance, correct? Now, if the ratio between displacement and distance is always less than or equal to 1, if the ratio between displacement and distance is always less than or equal to 1, what will be my ratio between velocity and speed? Similar to less than 1. Similar, correct? Similar, same concept. Because your ratio between displacement and distance is always less than or equal to 1. The same concept, velocity and speed is also less than or equal. Clear? Understood the concept? Similar analogy. It is nothing new that I am introducing. It is similar analogy, like the analogy between distance and displacement, what we have used, the same thing we are using between displacement. The same analogy what we have used between distance and displacement, the same thing we are using between velocity and speed also. Clear? Clear? Okay, now let's move on to the next question. Let's move on to the next question. Okay, these two questions are clear, these two concepts are understood. Now let's move on to the next question. Okay, now next question is, a body, or an object travels a distance, travels travels a distance of 2 meters, travels a distance of 2 meters in 2 seconds, travels a distance of 2 meters in 2 seconds, and 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 2.2 meters in the next 4 seconds, 2.2 meters in the next 4 seconds. Now the given question is, what will be the velocity of the body at the end of 7th second? What will be the velocity of the body, at end of 7th second, at end of 7th second? Clear? Understood? The given question is, a body travels a distance of 2 meters in 2 seconds and 2.2 meters in the next 4 seconds. You are supposed to find out the velocity of the body at the end of 7th second. Now think about the parameters that are given to you and what is that you are supposed to find out. They have given you distance and time, and they have asked you to find the velocity. Correct? At the end of 7th second. At the end of 7th second. Okay. So what equation or what formula that strikes you when you have an equation between distance and time? When you have an equation between distance and time, you only have one equation with it. You only have one equation, that is your s is nothing but ut plus half at square. You only have one equation with this. Correct? Now, so you write okay, you write 2 is equals to u into 2 plus half a t square. This is 2 square. Correct? This is your equation number 1. Correct? And what does it say? In the next and it travels 2.2 meters in the next 4 seconds. Now do not do the mistake of writing 2.2 is equal to u into 4 plus half a into 4 square. Okay, do not do that mistake, because this equation is always for your cumulative distance. So that means, what are you supposed to take? You are supposed to take the total distance of it. So that means in the first 2 seconds it has traveled 2 meters, In the next 4 seconds, it has traveled 2.2 meters. So that means you are going to talk about the distance that is covered in 6 seconds. Okay, that means in the 6 seconds it has traveled 4.2, which is u into, what is the total time? 2 plus 4, that is 6 seconds, plus half into a into 6 square. Correct? This is your second equation. Understood how we are writing the equations, or from where did we get the equation? I am assuming first equation, it's a direct one. You would have already noted this formula. It's a basic straight short formula, okay, which is s equal to ut plus half a t square. That is why in the first 2 seconds you've taken this. Okay, clearly. Now in the next 4 seconds, what happens is, okay, do not do the mistake of only taking the distance of the next 4 seconds. Okay, you are supposed to take the cumulative distance between all these. Okay, clear? Understood? Now from these two equations I can get u and a. I can get u and a. Okay. Now given question is what? Velocity of the body at the end of 7 seconds. Okay. Now if I have an equation of v, u and a, and I have t, that is 7 seconds. Which is the equation that I use? Nothing but v is equals to u plus at. Correct? V is equals to u plus at. I know u, I know a from these two equations. T is nothing but 7. I'll find out. Clear? You can go ahead and solve the questions, etc. But I am explaining you the concept of how exactly this is derived. Okay? Okay. So from these two equations, you find out u and a. Substitute in v is equal to u plus at. Clear? Simple question. 2018 paper. This has come. Do not do the mistake of equating 2.2 for the next 4 seconds and miss the bus. Okay, the option, if you see, they would have given for this scenario as well. Okay, they would be waiting for a mistake where students do this, and then you would directly go ahead and pick that option, and you would, in the exam, you will take that this is the right answer. You will come home, once you see the key, then you will say, such a silly mistake, how did I miss this? Okay, understand this. Clear? Let's move on to the next question. Okay, now next, if we go ahead, okay, clear on this? Now next question. Okay, let's see this. Now I am not going to give you this standard questions like, you have given v, you have given a, then you're asked to find out the time or distance, etc. and all. Let's see something different. Okay, let's see something different question. Now next question. Okay, next question. A body starts from rest. Okay, a body starts from rest and travels with a uniform acceleration of 20 meters per second square. Okay, a body starts from rest rest and travels with uniform acceleration of 20 meters per second square. Okay, 20 meters per second square. Now calculate the time taken by the body to cover a distance of 90 meters. Time taken by body to cover distance of 90 meters. To cover a distance of 90 meters. Of 90 meters. Correct? Now go ahead and do this. Simple question. Nothing complex in this. Simple question. Okay. You only have, if you see, you have three parameters. When I say body starts from rest, that means your u is 0, initial velocity is 0. Correct? Initial velocity is 0. Then a is nothing but 20. Then s is nothing but 90. S is nothing but 90. Correct? On this. Now, between these three, if three parameters are given, you are supposed to find out the fourth parameter. That is what time taken. Connecting U, A, S and T. What is the only equation that you have? You have S is equals to UT plus half a t square. Correct? This is the only equation that you have. So in this, your U is 0, A is 20, S is given, that is 90. You are supposed to find out time. T. Simple question. Okay? Simple question. Understood? Simple question. Now let's move on to the next question. Let's move on to the next question. Let's move on to the next question. Similar. I mean, the concepts remain same, but all you have to check is on the application. Okay. A bus travels. A bus travels. Bus travels. First one third of the distance. First one third of distance at 10 kilometers. At 10 kilometers. Okay. First one third at 10 kilometers. Next one fourth. Next one fourth at 20 kilometers. Next one fourth at 20 kilometers. Okay. Next one fourth at 20 kilometers, and the remaining and the remaining and the remaining at 40 kilometers, and remaining at 40 kilometers, and remaining at 40 kilometers. Now the given question is, what is average speed of the bus? Okay. Now question is, first one third is 10 kilometers. Next one fourth is 20. Is 20. The remaining distance, it is 40. Remaining distance is 40. You are supposed to find the average speed of the bus. Average speed of the bus. Average speed of the bus. Now the key concept here is, as usual, the formula, etc., everything remains same. Speed is nothing but distance or total distance by total time. Correct? Now, but the most important variation here is, if this is one third and if this is one fourth. Let's assume I have I have a straight line. Let's assume I have a straight line. Okay. Let's assume I have a straight line. Okay. If this is one third and this is one fourth, this is one third and this is one fourth, what will be the remaining part? What will be this part? Okay. Let's assume the total is S. Let's assume the total is S. Clear? Now, S, if the total distance is S, S minus S by 3 minus S by 4 will give me this part. Okay. One third of S is nothing but S by 3. One fourth of S is nothing but S by 4. Okay. The remaining part will give me, let's assume this is X. The remaining part will give me X, which is the distance I want to know in terms of S. Okay. In terms of S. Now, if you take out the LCMs, etc., and all, you get 5s by 12. The LCM between 3 and 4 is 12. 7s minus s minus s, that is how you are getting this 12. Clear? Understood? Okay, so the remaining distance is nothing but 5s by 12. Okay, now because you know this, now how would you proceed ahead? Simple. Total distance by total time. What is the total distance? It is nothing but s. Okay, what is the total time? S by 3. Distance by velocity, distance by speed. Okay, for the first one third it takes 10 meters. For the next one fourth it takes 20 meters, 20 meters per second. Okay, and the next 5s by 12 it takes 40. So this is s by 3 by 10 plus s by 4 by 20 plus 5s divided by 12 divided by 40. Clear? Understood? From this you can eliminate s and you get the remaining. Clear? Understood? Value you can find it out. I'm not focusing on the value, but I'm saying the concept or the logic behind this. The most important part in this entire equation is finding out this part. Finding out this part, which is the remaining distance that is traveled. Clear? So because you found out what is the remaining distance traveled in terms of s, you could have directly taken this distance by time in terms of expressed it in terms of distance by velocity, expressed it in terms of time, which is 5s by 12 divided by 40. That adds to your total time, and you found out the average speed. Got it? Okay. Now okay, these are the few questions which I want to discuss. Anyways, as we keep progressing, we will discuss more and more questions as well. Okay, now if you remember yesterday, we have talked about this simple differential concept or the instantaneous velocity, where I've told your instantaneous velocity is nothing but ds by dt. Correct? ds by dt, where you are finding out the change in displacement in that particular instance. That is why this is ds by dt. Correct? That is your ds by dt. Now in all the equations, say example, if s is nothing but t cube plus 2t square, and you're asked to find out the instantaneous velocity when t is nothing but 3 seconds. That means all I have to do is ds by dt, which is nothing but differential of t cube plus 2t square. Differential of t cube plus 2t square. Correct? Differential of this is nothing but 3t square plus 4t. 3t square plus 4t. Obviously differential, that is what I'm taking. Now from this I substitute t is equal to 3 seconds, 3 is equal to 3 seconds, and I get my instantaneous velocity when time is 3. At the instant when time is 3, I get the instantaneous velocity. Now so this is the differential that we have seen. Similarly, if you do the reverse of this, can I say my ds is nothing but vdt, correct? My vdt. Now which is nothing but an integral of this. Now if I am saying my velocity is nothing but 2t square plus say t, or however you want to do, you can frame your own questions, etc. Now let's for a second assume my velocity is nothing but 2t square plus t, and I am asked to find out the distance or displacement. Okay, now what do I do? 2t square plus t dt. Okay, now the time would be, say, in the first 5 seconds, what is the displacement traveled? So that means this is nothing but 0 to 5. The integral is 0 to 5, basic integral, which you have already seen in 9th and 10th classes. So this becomes now, if I am all I am supposed to do is integrate, okay, 2t square dt 0 to 5 plus t dt 0. Correct? Understood? So this is how you find out the displacement. Okay, if you differentiate v, you get displacement. If you integrate v, you get displacement. Sorry, if you differentiate s, if you differentiate displacement, you get velocity. If you integrate velocity, you get displacement. Both of them are interchangeable. Clear? Now in similar length, if I ask you, now that we have told this, if I ask you a is nothing but dv by dt, which is nothing but change in velocity by time. Okay, that is what your acceleration is. Correct? That is what your acceleration is. Correct? Now if I give you v is nothing but say t square plus 2t, and ask you to find the acceleration at time is equal to 2 seconds. Okay, all you have to do is differentiate this. Dv by dt is the equation, which is nothing but 2t plus 2, 2t plus 2, and at this point t, when t is equal to 2 seconds, you are supposed to find out dv. You are supposed to find out the acceleration. As simple as that. Clear? Now on the reverse of this, similarly, you integrate v, you get acceleration. Okay, the cycle is similar. The cycle is similar. S v a, you differentiate, you get velocity. You differentiate, you get acceleration. On the reverse cycle, this is same. You integrate, I get v. You integrate, I get s. Clear? Understood? Now all these concepts, or all this is derived from your most important equations of your graphs. Okay, now in the graphs or the slopes that we have seen yesterday, so we have seen that, say example, if this is my s and this is my t, I have told you that generally how do you do is, you plot the graphs. You have the standard measurements that you take. You put x-axis, y-axis. In the x-axis you have t, in the y-axis you have s. So if, let's say, this is t square, so this is c square, so you have 0 0, you have 1 1, you have 2 4, you have 3 and 9, because it is t square. Correct? So that is how you plot it on the graphs, and then you get it. You plot it and then you get it. Clear? Understood? Okay, now similarly, in similar lengths, now there can be multiple scenarios where they would have asked you, let's say this is my time, this is my distance. Okay, let's say this is a, this is b, this is 5 10 15. Okay, on the time axis. Now let's say this is say again 5. Okay, now if they ask you to find out the velocity, if they ask you to find out the velocity if they ask you to find out the velocity along this, now what will be the answer to this? Now you all know ds by dt, or velocity is nothing but the slope of this. Velocity is nothing but the slope of this. Okay, now yesterday we have seen slope is nothing but your tan theta. Correct? Slope is nothing but your tan theta. Okay, slope is nothing but your tan theta. Generally, what is the tan theta? Generally, how in any graph, say example, if this is my graph, okay, this is your theta, which is tan theta. Okay, now if I am supposed to find out the slope of this, what would you be doing this? What would you be doing? So this is my y, x2 y2, and this is my x1 y1. So your slope is nothing but slope, or tan theta, or slope is nothing but y2 minus y1 divided by x2 minus x1. Correct? Okay, similar thing. So here also I am using my slope to find out the velocity. Correct? Here also I'm using my slope to find out the velocity, correct? So all I have to do is find the slope, which is y2 minus y1 divided by x2 minus x1. At this point, okay, 0 comma 0 is my x1 y1. What is my x2 y2? X2 is what? 5 and 5, correct? 5 and 5, okay. So 5 minus 0 divided by 5 minus 0, which is 1 meter per second. This is the average velocity here, okay, for this path. Now tell me, what is the average velocity for this path AB? What is the average velocity for this path AB? You have guessed it right. It is 0. Why? Because there is no change in displacement. The displacement, if it is phi at A, the same thing is at B also. There is no change in displacement. Now, only if there is a change in displacement, there is a change in velocity. That is how you are getting the velocity. Correct? Correct. Now, similarly, in the similar length, if I am asking you to find the velocity at this, now what is this equation? Tell me. This is nothing but 10 comma 5 at this point, whereas this is 15 comma 0. Correct? So here my y2 minus y1 divided by x2 by x1. Okay, y2 minus y1 divided by x2 minus x1. This is nothing but at this point, what is my y2? Y2 is 5. Y2 is 5 minus y2, 5 minus y1, which is 0, correct, divided by x2 minus x1. What is x2 minus x1? This is 15, this is 10, so this is 15 minus 10, which is nothing but 5 by 5, correct? Understood? Understood the concept? Clear? So this you find out the slope, this you find out the slope, this you find out the slope, and you get the velocity, okay, from this graph. So the idea is slope of st graph gives you velocity. Slope of st graphs gives you velocity. Slope of st graphs gives you velocity. Clear? Sorry, this is actually 5 minus 10, which is minus 5 by minus 4. Okay, so therefore the velocity is minus 1. That is why it is decreasing. Okay, velocity is minus 1. Okay, clear? So the slope of st graph gives you v. Understood? So similarly, in similar length, if I extend the same analogy to vt graph, velocity time graph, what would you get? Acceleration. In the same analogy, if I extend this to vt graph, what would you get? You get acceleration. You get acceleration. Clear on this? Because the previous concept, what we have seen, differential of s gives you v, differential of v gives you a. Correct? The reverse of this, same. Integration of this gives you v, integration of v gives you s. Correct? Because your slope is nothing but change in velocity by time, you are getting velocity in the slope of st graph. Because change in velocity gives you acceleration, you are getting slope of vt graphs gives you a. Understood? Clear? Okay, now if you go through all the graphs, you have multiple questions which you can see, which you can go through. Say example, you can have, now one of the graph that we have discussed is trapezium. Second, you can have like this, it can go on. All you are supposed to do is find the points of this and find the slope. So the slope is 0, the slope is 0. So similarly, I can have a negative graph as well. I can have a negative graph like this. Okay, all I am supposed to find out is the slope. Okay, On slope we will discuss. So this is the angle that it makes. All you are supposed to do is find y2, y1, x2, x1. Okay, find y2, y1, x2, x1. Now in other concepts, if you see, they would give you, say, velocity time graph. Okay, and let's say this is a triangle. Let's say this is a triangle phi. So this is phi. Let's say this is 10 and this is 0. Okay, velocity time graph. Okay, from this remember, we have told that slope of vt is a, and slope of st is going to give you v. Correct? Slope of st is going to give you v. Clear? Understood? Now if I am talking about a graph where there is v and t, okay, think about it. What is that you can find out? If there is a graph of v and t, okay, velocity of v and t gives you the area under the graph v in t. This area gives you displacement. Okay, remember this. Area of v and t gives you displacement. Gives you displacement. Okay, so if in the previous question, if you've seen, if this is v and t, 15. Okay, the area under this graph, this area this area is nothing but your displacement. And remember, it's only for vt graph. Okay, not all of the graphs, only for vt graph. The area under that vt gives you displacement. Now how would you find the displacement of this? Either you can directly apply the formula of area of trapezium, or the next simpler way to do is find the area of this triangle, this square, and this triangle. Add all these three, 1 plus 2 plus 3, you get the displacement. Clear? Understood? Now in similar lens you might have seen couple of questions where they would say, where they would give you negative graphs as well. Say example, let's say this is 4 and this is 8. Okay, similarly this is 4, this is 8, this is 12, and on the negative side I have -4 and -8. Let's say this. Now assume this is v and this is t as usual. The x-axis represents time, whereas the v-axis represents velocity. Okay. Now tell me if I have a graph like this. Tell me if I have a graph like this. Okay. Tell me I have a graph like this. Okay. Now if I ask you to find the displacement, all you have to do is find the area of this. Now area of this is nothing but 4 into 8. Okay, but here if you see, in this rectangle, even though this is 4, but this is -4. Correct? This one is -4. Clear? So this is 8 into 4. This rectangle is 8 into 4, whereas this square is negative. Correct? So minus, you do 4 into 4. Clear? Understood? So this is 32 minus 16, therefore 16. So your displacement is 16. Clear? Understood? So you will definitely have couple of questions coming on this graphs, which again, like I told you, we will see. But remember this: area of V and T will give you displacement, whereas slope of V and T will give you the acceleration. Clear? Clear on this topic? Clear? Now let's move on. Now the standard equations you've already known. If you see, you know that V is nothing but U plus AT. These are the laws of motion that you have. Okay, and then you have the next one, which is V square minus U square. V square minus U square is nothing but 2AX. Okay, you only have these three equations. Now if you remember, I had just told you your A is nothing but dv by dt. Correct? Change in velocity by change in time. Correct? Now if I on the similar lens, if I integrate this, that is, if I put this, A is nothing but d dv by dt, where I'm talking about v being the final velocity, and u being the initial velocity. Sorry, where I'm talking about v being the final velocity and u being the initial velocity. Okay, correct? Similarly, if you see this, s is equal to ut plus half at square. Okay, s is equal to ut plus half at square. Okay, now all these equations can be derived from this formula. All these equations can be derived from this formulas. I mean, this you can derive from this, while s you'll have to take, s is nothing, sorry, your v is nothing but ds by dt. V is nothing but ds by dt. Okay, now all you have, say example for a second, let's assume my v is nothing but u plus at. Correct? My v is nothing but u plus at. If I substitute here u plus at different is ds. Correct? Now if I am integrating with respect to time, so this becomes u dt plus at dt integral, which is nothing but integral of ds. So this becomes s, because u is a constant, it comes out. Integral of a constant is, you have t plus, now a again is a constant, so a comes out. So integral of t dt is nothing but t square by 2. So this is how you have derived this equation. Okay, this is how you have derived this equation. Similarly, we can derive your other equation of v is equal to u plus at using this equation. Clear? Because all I have to do is integral of dv is nothing but a dt. Because a is constant, I will say my, let's take this, I'll do this at the bottom. Okay, I'll come here, let's take this. Now if I am saying a is nothing but dv by dt. Okay, dv by dt. Clear? Now I am saying dv is nothing but a dt. dv is nothing but a dt. Now for, if I am integrating, this starts from u and v. Correct? And whereas this starts from 0 to t, because when t was 0, your initial velocity is u, when t is t, your final velocity is v. Now if I integrate this constant dv, so all I have is v minus u is equals to at, therefore your v is equal to u plus a. This is how you derive it. Now from this you can find out the second equation, you can get this. Similarly, you can do the third equation derivation as well. That is v square minus u square is equal to 2as. You can do this as well, but understand there is no term t in this. There is no term t in this. So can I simply write? Can I simply write if I am saying okay? I'll just take a new sheet. Okay. What is that we have said? V square minus u square is equals to 2as, correct? Now there is no term t to integrate this and get this derivation, correct? So all you have to do is introduce this term. So can I say my a is acceleration is nothing but dv by dt, correct? A is nothing but dv by dt. Now can I introduce ds by ds, integral of ds by ds, and I will write this as dv by ds into ds by dt, ds by dt. Clear? So my a is nothing but dv by ds into ds by dt, same thing. Clear? Now what is my ds by dt? Nothing but v, velocity. So dv by ds is what I will integrate, is what I will integrate. Okay, so ads is nothing but vdv, ads is nothing but vdv. Now if I integrate this from 0 to s, here I will integrate from u to v, because when distance is 0, when while your initial velocity you have assumed it is u, the distance or displacement is 0, correct? So here you have a into s, you have here v square by 2, which goes, if you are doing this u and v, you have, that is how you derive v square minus u square is equals to 2 from this. Clear? Understood? It's a simple small integral and differential concepts which you can use across all graphs, which you can use across all graphs for finding the slopes, for the areas, for the displacements, velocities and acceleration. And the same formulas have been used to same integral and differential concepts have been used to derive your formulas as well. Formulas of your kinematics between u, v, a and t and s. Okay, between these five parameters all the formulas have been used, all the derivations have been done using your integrals and the differentials. Okay, now you have just seen how we have arrived all the three formulas. You have just seen how we have arrived at all three formulas. Okay, between v, u, a, s and t, all five you can use this any differential or any integral calculus and you can get this derivation formula. Okay, you don't have to by heart it, but obviously you are supposed to know all these formulas, because in the exam you cannot keep deriving or integrating all these formulas to get the answers. Okay, you understand the basis from how did we arrive these formulas. Based on that, the same concept of how we have seen the slopes, the integrations, the instantaneous ds by dts, that is the same basis for all your formulas and concepts. Clear? Understood? I hope I have made myself very clear. All these things are simple topics. The moment you understand the question and the concept thoroughly, 90% I would say it's done. The remaining 10% is you will have to put it in the exact formula and then give the mathematical solution for that. That's all. Nothing more, nothing less. Clear? Understood? Sure. So in the next class, we will further discuss on these problems, and then we will move to motion in the under the gravity. That is, whenever the ball is thrown up and when a ball is thrown down, how is the acceleration getting different? What phenomenon and what happens and what concepts do apply in those cases? That is what we will see in the next class. Okay. Thank you.